Hi folks, this tutorial deals with the use of Sketcher and Law in a very simple form for 3D Experience Catia Release 2025X. I have to point out that what I'm going to show you is not an efficient way of doing the problem that I have in mind. It's just that I want to demonstrate how Sketcher can use laws in order to achieve certain tasks. Okay. And let me remind you that in 3D experience, what is buried is actually the CATIA, not quite V5, but it's V6 modified. So that's why we refer to it as 3D experience CATIA. Uh, but I have prepared a similar tutorial for CATIA V5 that's in my channel. All right. Let me first point out that the law in 3D Experience can be found in the Tools section or Tools tab of the part design. And if you cannot see this thing, actually, you're going to have to click on that triangle. If you cannot see this thing, click on that triangle and it will show it to you. There is some uh, documentation available, which is not substantial, but it at least tells you that what is the purpose of a law. It's a single input, single output uh, entity. Now, after I do a very simple case, I will come back and do this problem for you, but not initially. Initially, I will do a very simple point, single point. Now, what we're going to do later on is a bunch of points, 6 points that are given with the correct coordinates, such as 0, 0.25, 0.5, etc. But the heights are supposed to be coming from either x squared if x is less than or equal to 1, or a constant height of 1 if x is bigger than 1. Now keep in mind that I can't write this thing, units don't match, so I have to modify that later on when I write my law as x squared divided by 1 inch. Otherwise, this is going to be inch, this is going to be inch squared. Okay. But when you click on the f of x or law, this pops up. It gives you information about the law name and the author. And when you say OK, then it gives you the dialog box that allows you to write your code here. Of course, you're going to have to define formal parameters here, which are going to be internally used uh, for the law. Now, the law that I'm going to be using is if x is less than or equal to 1 inch, the coordinate x is less than or equal to 1 inch, then y is going to be square of x. And remember, I have to modify that, normalize it so that it becomes inch equal to inch, else y equal to 1 inch. And once again, I point out that these formal parameters are only used internally. You will not see them anywhere in the tree. However, if you have parameters, rename parameters or user parameters in the tree, you can use it within your interrogation area, code area. The first problem that I'm going to do is this. So I'm going to create a single point with these coordinates in the sketcher. And then I select the vertical dimension and right click, go to edit formula. When you do that, it takes you to this dialog box. Now, because I have conditional if statement, I cannot write stuff here. But what I can do is I can click on this law, click on that law. So it gives me the information about the law that I have in the tree. And then we'll come to these slides later on. Put the law there and then click on the law. You search here in this area, search here for the law. When you found it, double click on it or select it, and then uh, double click uh, on the evaluate. It puts it right there, and we're going to put stuff in between the parentheses. Okay, so between those parentheses, I set that horizontal distance. It's going to take this thing and square it. So that height is going to be equal to this squared, except that it's normalized by 1 inch, and we will come to these later on. So once you do that, this height becomes 1 because 1.693 is not bigger than 1. Sorry, 1.693 is in fact bigger than 1, and therefore the height is going to become 1. We'll see that. There are some comments here that I'll talk about later on. Okay, let's go there. All right, so we are in part design, and if you click on the Tools tab right there, Tools tab, and scroll down here, try to find your law, the law icon. You go until you reach this section, past formula, okay? And if you cannot see it, just click on see your formula. Click on this uh, icon. Click on this icon. This icon means triangle. And what it does, it gives you the law popping up right there. Click on it. Here is the name of the law, the author, the date, and then we say okay. And what I'm showing you now is uh, where we got the law editor, and if you click on OK, this dialog box will pop up. Okay, so let's go there, and we already did. Now we define our formal parameters. They're of type length, so let me change this thing to length. See if we can find it more, or length is first here, right here. All right, click. It's going to, first one is going to be X. Another one, this is going to be Y. And we are good with our formal parameters. Now we can start writing our code. If X is less than or equal to 1 inch, then Y equal to X to the power 2. But remember, you have to normalize it so that inch becomes 1, inch becomes inch. So it's going to be divided by 1 inch. Else, Y equal to 1 inch. Okay, so that's my law. Now, if you click on this this arrow here, if there are any syntax error, it'll show you. I have none here, but let's hypothetically say I put a parenthesis there. Obviously, that's meaningless. So if you click on the arrow, it'll tell you there's a syntax error right there because of that parenthesis, of course. So just take it away, and we are good. Check it out. Yeah, no syntax error, and then we say OK. So here we have our law showing up. And if you double click on it, you can always go there and make the appropriate changes if you need it. Now, the next thing is I'm going to create do my first example, which is creating a point like that. So let's go ahead and do that. On that vertical plane, I will sketch. This is, remember, we're doing this thing in Sketcher. You click on the point, you select any point that you want. So, for example, I can put those coordinates. Those coordinates were 1.693, 1.693 for X, and for Y, it happened to be in the drawing 1.732. 1.732. There we are. It has been created. The point has been created, and I can move these things. Let me see. There is your X value, and there is your Y value. So basically what I'm showing you this diagram. Okay. Now I put the cursor on the vertical dimension, right click, edit formula, all the way down, offset object, edit formula. And this pops up. So what I have shown you now is this slide, okay? All right, so I'm showing you this slide. So if you select the law from the tree, it'll take you to the place which is related to the law, and that is, let me see for a second, that is this slide. So double click on this, left double click on that, it puts it there, and then start searching here to find your law right there. Notice that this is that slide or that figure, and finally you double click on that, evaluate, and do the rest of the thing. So go back here, double click on double click on this, it puts it there. And for the thing in between the parentheses, you select this horizontal dimension. Okay, so that slide is now this. Okay, and we say okay. The automatic update message, say yes, and notice that immediately it changed this thing to 1 because 1.693 is bigger than 1. That height must be 1. So I have done for you this problem. Okay, this is what happened. Changed it to 1 because of my law. And now I'm going to go back to this problem and do that. So we go here. First thing I'm going to do, I exit this, exit that. And I don't want that sketch. That was just for demonstration purposes. Delete. Enter again. Enter again. And I will create these 6 points. Their X is correct, but their Y is not. Okay, so let's go ahead and do that. Let me start with the points. Because the X is correct, I might as well put the correct for the first one, correct X, 0. And for this, it really doesn't matter. I'll make this thing so that it's easier to manage these things. I'll make it point, I don't know, 6. Okay, point has been created here with the dimension x equal to 0 and height of 0.6. Let's do another one. The next one, my x is 0.25. And I'll put down here an x of, I don't know, maybe 0.7, 0.6. That's fine too. Enter. So what did I do here? Yep, that's okay, no problem. So notice that the point has been created there. There is the horizontal distance, 0.25, and the height, I didn't want it to be like that. Maybe I typed incorrectly, maybe 0.7, doesn't matter. Bring it down a little bit. Okay, very good, good. Another one. I know that x has to be 0.5. To make my job easier, I put the 0.5 here, and yeah, 0.8 makes no difference. And enter. There is my other point. Let me move this thing there so you can see. So far I have 1, 2, 3. The heights are not right. Okay, we have to fix this thing. Another one. Your x is 1 and your height is, I'll just put down 0.8 also. Enter. There's the other one. Okay, let's do another one. 1.25. 1.25. And for the vertical, I put down 0.9. There. I'll move this thing so that you can see it here. There's the other point. And the last one, your x is 1.5, 1.5, and your height is, I'll just, yeah, 1.8. Makes no difference. There we are. Okay, so basically what I've done here, I have created 6 points. 1, 2, 3, 4, 5, 6. Okay, just so that we can see them better, I'm going to bring this thing down below, this dimension. I'm having a hard time bringing this thing down. Well, let me try. Let me try this one. Let me try bringing this one down. Where is this? This is 0.25. Okay. There is your 0.5. This is 1. There's your 0.5, just so that I can see things better. Okay. Where is a 1.25? It's right here. And where is the 1.5? It's down there. So notice that, and there's the zero. Now zero, I'm having a hard time bringing it down. I don't know. Just leave it the way it is. It doesn't matter. So 0.25, 0.5, okay, etc. And just so that I can see these better, I'll move them to the left. Okay. So these are the 6 vertical heights. Where's this? Right there. What is this? Yeah. All right. Let me make this thing a little bit smaller so that it's not way up there. So I'll make it 1.3 or something like that. Much better. Okay, good, good. So what was the strategy? We select, let's start with this first one. This is the height of the one at zero. See that? This is the height at zero. Put the cursor there, right click, edit formula. There we are. Select the law. This is law number 1. Search here for law. Select evaluate. And in between the parentheses, put the horizontal dimension of that first point, which is actually 0. Select this. And then we say, okay, notice what happens. Immediately this will jump down because the height becomes 0. Update. There we are. So it jumped down. It jumped down to this location. It's right there. It's right there. It's right at the origin. Next one. Select this. Select this. Right click. Edit formula. Okay. Click on the law. Put this thing up there. Search for law here. Select evaluate. Left double click on the evaluate. And put that horizontal dimension for that point, which was 0.25 right there. And then we say, okay, no, immediately it will jump from up there to a height of 0.0625. Okay, right there, you can see that. So what I'm doing for you is going through these steps, okay? These steps. I'm going for you through these steps. Okay, let's do another one. That is this height. This is the third point. Put the cursor on it. Right click. Edit formula. Select the law. Put this thing up there. Search for the law here. Evaluate. And then put the horizontal dimension associated with that third point, which happens to be, I believe, that 0.5. And then say, okay. It's down here. So 0.0625, 0.25. That's right. Yeah. Next one. Put the cursor there. Right click. Edit formula. Select the law. Put the law up there. Search for the law in this left pane. Put it there. And then the horizontal. Horizontal, that'll be this. And then say okay. So what happens, this is your third point, which goes to the height of, should go to height of 1. You can see that, height of 1. Then the next dimension is going to be this. Right click. Edit formula. Select the law. Law number 1. Search here. Evaluate. And that distance of 1.25 right there. Say okay. Of course, it's going to come down to a height of 1. You can see that. See, height of 1, height of 1, as it's supposed to be. As it's supposed to be. And finally, the last one, this height. Right click. Edit formula. Select the law. Put the law name there. Search in here. Put evaluate there. And finally, the horizontal distance, and then we say okay. So what happens here? What happens here is I have created my 6 points. Let me hide these dimensions so that you can see these things better. Kind of let me hide these dimensions. I mean, there's a more efficient way of hiding these dimensions instead of doing it one by one. I can start like this, control. Let me see now. Control this, control. Show. Okay, so there's a few more. That guy and this guy and this fellow hide and show, and that fellow hide and show. Okay. If you cannot see it easily, let me change the background to maybe let me change the dot mirror there. So I have a point here which you cannot see because they're coinciding with this axis. This is 0, 0. This is 0.25, 0.0625. This is 0.5, height of 0.25. This is 1, height of 1, 1.25, height of 1, and 1.5, height of 1. Okay? So this concavity, by the way, is not correct. It should be going like this. Instead of concave down, it should be concave up. But it doesn't matter. The point is that what I did, I managed to create the correct heights. And for example, if you insist, I don't know whether you're insisting or not, you can put a spline through that and it will look, for example, like the graph that I have for you. Spline from this point and that point and that point and that point. Okay. Except that this last one, I kind of inadvertently selected points here. I meant to say it's select, but it's right here. Let me delete this. Try it again. Where is this? Spline to this point, to this point, to this point, to that one. There we are. So this is basically the correct concavity of that curve. Should go like that. And then of course there's a straight line between these. Okay. A couple of comments you might say, well, wait a minute. Okay, so could I not have done a formula, regular formula? The problem is that you can't have if else within a regular formula. And you might say that, okay, even if I don't have a if else, uh, what if I just have, for example, y equal to sine of x something something? Problem is that you have to write each one of those one by one, again, in every formula. This way, I define one formula or one law at the beginning, and then use it repeatedly. Okay? Yeah, that's pretty much it. Good luck.